Welcome to another Diploma Program Physics summary video on 5.1 electric fields, where we're going to go through a number of fundamental concepts used in this topic and other topics. So the first one is the concept of charge, which is a fundamental property of matter, whose symbol is Q or big Q, and the unit is the coulomb. And one important amount of charge you might need to know is the fundamental charge on the electron, which is 1.6 times 10 to the minus 19 coulombs, which you're given in the data booklet, but it's good to know off the top of your head. Between two charged particles, there exists a force, which is given by Coulomb's law, Kq1 Q2 over r squared, where Q1 and Q2 are the charges on the respective charge, and r is the distance between the centers of the charges. If I have like charges, they will repel. If I have opposite charges, they will attract. Now, the region in which a charged particle experiences a force is called an electric field, and field lines go from plus to minus, i.e. in the direction a positive charge would be accelerated. And the tighter the lines are together, the stronger the field strength. If I have a point particle, then the field lines would radiate, in this case, outwards from the positive charged particle. If I had a negative particle, the field lines would point inwards. And an important quantity is electric field strength, which is defined as the force per unit charge for a small test charge placed within the region of the field, whose units are Newton per Coulomb. Moving on then to the next slide, still on the topic of electric field, another important quantity is current, capital I, whose units are the ampere. It's a measure of the flow of charge. It's the rate of change of charge, or delta Q divided by delta T. In circuits, direct current moves from the positive cell of the battery to the negative cell, which is actually the opposite to the direction in which electrons flow. Electrons are the charge carriers in conductors. And one can derive an alternate formula for current, which is N big A VE, where N is the number of charges per unit volume. So the better the conductor, the larger the number of charges per unit volume, therefore the larger the current. A is the surface area of the cross-sectional area of the wire. The larger the cross-sectional area, the larger the current. V is something called the drift speed of the electrons, and E is the fundamental charge on the electron, which we went through just a second ago. Finally, an important quantity we have to define is something called potential difference, sometimes more commonly called voltage. Its symbol is V, or sometimes shortened to PD for short, and the unit is the volt. It's defined as the work done per unit charge moving a charge across an E field. So if I have a positive charge here, and I try to move it against the field, I need to do work to do that, and that work per unit charge is defined as the potential difference.